Hi, my name is dhogenkamp, and I'm the OEM account specialist here at CBT with 5 mistakes to avoid when sizing your next linear motion system. First, don't forget about gravity. Sizing software like Rockwell Automation's Motion Analyzer often defaults to horizontal motion when you set up a new axis. In order for the effects of gravity and coefficient of friction based on mass to be calculated properly, you'll need to make sure that you orient the axis properly in your setup. Always account for the efficiency of your system. While ball screws can have efficiencies up to 90% due to rolling versus sliding friction, Acme lead screws can have efficiencies ranging 20 to 80% depending on the helix angle of the screw. All moving parts are susceptible to friction, so it's important to accommodate not only the efficiency of the actuator, but also the friction associated with any of the other guidance systems in your application, as this can have a dramatic difference on the size of the components needed. Be sure to fully account for the moving mass of your system. It may seem obvious, but things like wireways, cable track, air lines, and sensors are easy to forget about. Also be sure to account for changing mass if parts are picked up or dropped off during a cycle. In applications that have high acceleration, off-center loads can cause bending moments that might shorten the life of the actuator as well. So it's important to understand whether or not your actuator can fully support both the static and dynamic moments in the system. Don't forget about the inertia mismatch of the system. The inertia mismatch is calculated by comparing the inertia seen by the motor to the motor's rotor's inertia, and is critical with respect to stability and sizing of a servo system, particularly with respect to rack and pinion and belt-driven actuators. The reflected inertia of those systems is calculated by assuming the mass of the system exists at the pitch diameter of the pulley or pinion gear. One way that we can accommodate inertia issues is by introducing gearing. So for example, if we can introduce a gear ratio of 3, it can reduce the inertia mismatch of the system by a factor of 9. This is a powerful way to fix inertia problems if the speed of the system allows it. Don't forget about environmental factors. Heat, liquids, dirt, and other contaminants can severely affect the life of linear systems. Extreme temperatures can affect the performance of lubricants and plastics in a system, and contaminants can damage the moving parts of ball screws and linear guides in a system. In some cases, the actuator itself can be a source of contamination, and things like special seals or positive pressure can help mitigate these problems. Need help sizing your next linear system? I'd love to help. Let's chat about ways in which CBT can help improve your business.